This is the first of 3 videos about the bubble sort. This video introduces the bubble sort algorithm and explains how it works. In the second video, you'll see some pseudocode for a bubble sort and some enhancements that can be made to the algorithm to make it more efficient. In the third video, you'll see how to implement a bubble sort in Visual Basic. Let's suppose we want to sort this list of numbers into ascending order, with the smallest first and the largest last. We begin by comparing the first 2 numbers, and if the first of the 2 is bigger than the second, we swap them over. We then compare the next pair of numbers, and if the first is bigger than the second, we swap them. In this case it isn't. We then compare the next 2 numbers, and if the first of the pair is bigger than the second of the pair, we swap them. And then we compare the final 2 numbers, and if necessary, we swap them. We've scanned across the list once. Now we need to scan it again. We compare the first pair of numbers and if necessary swap. We don't need to this time. We compare the next pair. This time we do need to swap. We compare the next pair and we need to swap again. And just to be sure, we compare the last pair of numbers. And now we scan the list again. Compare the first pair, if necessary swap. Compare the next pair, if necessary swap, we don't need to. Compare the next pair, and compare the next pair. And one more time, just to be sure. Comparing pairs, swapping if necessary, and our list is sorted. Now let's see the algorithm working again, but this time on a bigger list of numbers. And notice that this time the numbers are in completely the wrong order, so every one of them is going to need to move. Just as before, we compare and swap if necessary. Of course, a computer program can do this very quickly indeed, but here you can see what's going on. The bubble sort scans across the list, comparing pairs of items, swapping them when it needs to. Each time the list is scanned, the next largest number finds itself in the correct position. One at a time, the bigger numbers are making their way to the opposite end of the list, a bit like bubbles rising up through water. That's why it's called a bubble sort. It's also sometimes called a ripple sort because the larger numbers are moving across like the ripples on the surface of a pond when you throw a pebble into it. You can see how much longer it takes to sort a list of 10 items than it does to sort a list of 5 items. If there are 10 items in the list, then the list needs to be scanned 9 times to ensure that everything's in the right place. Why 9? Well, consider this. If there were 2 items and you put one of them in the right place, the other one must be in the right place. It's the same idea. If there are 10 items and you put 9 of them in the right place, then the remaining one must be in the right place. We scan a list, however many items there are, -1 times. Let's see what the bubble sort algorithm looks like when it's written down in words. This is our scanning loop. A pair at a time, items are compared. If the first of the pair is bigger than the second of the pair, their positions in the list are swapped. And this scanning loop needs to run several times. However many items there are in the list -1 times to be precise. So, if there are 5 items in the list, it needs to be scanned 4 times. If there are 20 items in the list, it needs to be scanned 19 times. To summarise then, the bubble sort scans a list, comparing pairs of values and swapping them if necessary. For n items in the list is scanned n-1 times. The bubble sort is good for small lists of data. You've seen how much more work it has to do when you double the amount of data. And finally, the bubble sort isn't just for sorting numbers. You might want to sort a list of names into ascending or descending alphabetical order. In the next video, you'll see how you can get closer to writing a bubble sort program.